Hi viewers, welcome to my YouTube channel Green Treasures. Today our focus will be grafting and its types. We will understand the art of plant connections. Here we will discuss the definition, historical background, and what are the requirements for successful grafting, and also how we will select and how we will handle the cyan wood, and then what are the different types of the grafting. You will see during this discourse, you will find that I have put number of photo features of each type of grafting. It is just to help you so that you will practice these types of grafting at your own. So what we mean by the grafting first. First of all, this grafting is basically a horticultural technique, or it is a technique of uniting the plants. The art where you are making the connections between the plants is a French word which is basically named as grafter, which means to unite. So it is basically a horticultural technique which involves joining together of two different plant parts. So we have is a art where we can connect the two plants. What we will connect? We will connect the two plant parts. One will be the part which will have a good quality, will have a desirable traits, and these two plants which will be of different varieties or the species. So we will make a single plant out of the two plants. So what we do, we just take two plant parts. The one part which will include the top branch, that is termed as the scion. Scion is the aerial part, and that aerial part which has the desirable traits which you select, which has certain traits which you are liking, and then the bottom part is portion is termed as the root stock. The root stock is one which you are selecting, which will be a rooted plant, which will have a strong root system. So by this horticultural technique, you are joining the two plants together, which is of two different plant part, two different varieties or species, and so that you get a single plant, new plant, which will be named as an hybrid plant. So the two parts which we join here is called as the scion and the root stock, or which is also called the stock. So it can be seen here. You have a aerial foliage which will be a short segment of a stem, that is called as the scion, and this will be a rooted portion which will be called as a stalk, and you will make different types of these wedges here when you will insert this scion into this stalk, and then after joining them, putting a clay which is called as the grafting clay, you will see there will be a successful grafting, that is the foliage will be formed there. You will have a plant which will have a scion and a stalk where a successful grafting is there. That means it is a art of joining the two plant parts together, and it is a form of a plant propagation, which is basically asexual or colonial method of propagation, where it is useful to combine desirable qualities of two plants, because when you find a plant, one has a good quality, another plant has a some other good quality. Now you want that you have a plant where both the qualities are together. So you take, suppose you find a superior fruit qualities are there, you have a disease resistance, and at the same time you have a robust root system in one plant. What you will do, you will take this part which will be a scion, and this will be as a stalk. So it is a development of improved and the resilient plant. What will be the result of this technique? You will have a improved and a resilient plant, because you are taking a robust root system, and it is used to propagate desirable traits. Desirable traits is which you see in a fruit tree, which you see in a ornamental plant, which you see in certain vegetables also, to achieve specific characteristics in plants. And a new plant or a hybrid plant has a more vigor, which we call as the hybrid vigor. So usually this practice of grafting is practiced by highly experienced nursery operators. So nursery operators are basically trained to do the plant grafting. In addition to this, let us see first what is the historical background. It will be just a brief nutshell, because grafting is an ancient practice. We find its references in Bible, ancient Greeks and ancient Chinese texts, indicating that grafting was practiced in Europe, Middle East, and Asia by at least the 5th century BCE. You will see Egyptian literature. Egyptians used it to improve fruit quality and ornamental plants. And Theophrastus, a Greek philosopher, he documented grafting methods in his works. Romans used grafting beside fruit trees extensively in agriculture. That means when we see the historical background of grafting, it is an ancient practice, and Chinese have played a notable role. And what are the notable Chinese contributions? Because Chinese expertise on plant grafting had a lasting impact on agriculture globally. Ancient Chinese horticulturists, Emperor Shennong pioneering experimentation with grafting. Ancient Chinese agricultural text mentioning grafting techniques. The Six Secret Teachings of Liu Toi is a comprehensive guide containing grafting methods. Notable contributions by Chinese is in fruit tree grafting, peach, plum, apricot, and they did a refinement of the techniques, the improvement of grafting processes, and it had a global influence. That spread of Chinese horticultural knowledge, because Chinese have contributed greatly in the grafting techniques, though it's a very ancient old practice. And let's see now, with this picture you will see that grafting techniques in the 17th century. This picture shows at least 9 different types of grafting methods. 9 different types of grafting methods. You see, this is one grafting, this is one grafting, and then so this is taken from a Robert Sherrock's The History of Propagation and the Improvement of Vegetables. So this is this plate depicts that grafting is a very ancient old practice. And what we need if you want to do a grafting, you need a special pruning, this that is called a sketcher. You need a grafting tape, you need a grafting knife, you need a clear transparent bag, you need a cable ties for tying it, and you need disinfecting agent such as alcohol swabs. And you have this time available professional grafting tools also. And when you take these tools, before you go for the grafting, you have to use the disinfectant to your tools before you start your grafting, because you are cutting the plant. There are every chances that it can have an infection on the cutting portion. So what are the requirements for the successful grafting? 5 important requirements are: first and foremost should be a compatible stock and scion. The compatibility is very important. There should be usually closely related plants. For example, you have 2 apple cultivars. So compatible stock and scion is must. Second is, there should be an intimate contact between cambium tissue of a stock and the scion. We will I will make it clear in the preceding slides that cambium tissue, which is a characteristic feature of the dicots, which is responsible for meristematic growth or the secondary growth or the formation of new tissues, xylem and phloem, is important for this grafting, because this is because of this cambium there is a contact between the scion and the stalk. So whenever you make an intimate contact, that cut surface should be held together tightly by wrapping, nailing and wedging, which we will see in all other methods also. So grafting operation must be done when both scion and stalk are physiologically dormant. It is very important. You are uniting the two plant parts when they are dormant. That is, no sprouting is there. The leaves have their, or they are physiologically dormant. That can be during winter or that can be early spring. And when you are grafting, it is to be the cut surface is to be the area is to be covered. That means covering graft union with a tape or a grafting wax and placing the graft in a moist material or covered with grafting frame to ensure protection from desiccation. That means you have to protect your graft, you have to protect your scion. Scion is to be protected because it should not lose its moisture, and then also the aftercare is very important. What is the role of a vascular cambium? As I said, vascular cambium is basically a meristematic is a tissue is a meristematic tissue, and which is responsible for the formation of regeneration or the formation of new tissues also. It plays a crucial role. It is facilitating the union of vascular tissue of scion and rootstock. You know, there is a cambium, xylem and phloem is there, and the xylem and phloem is basically formed from the cambium, which produces a xylem and the phloem. And it is also responsible for the formation of the secondary growth in the plants. That is why you will find the grafting is more abundant and more successful in the dicots only, because that has a vascular cambium or the vascular tissues are there. Vascular cambium between two plant parts, when the two are combining together, it will promote the nutrient and the water transport, enables integration of different plant varieties or species, and promote successful grafting. So vascular cambium is very important tissue which is responsible for connecting the two. That is why there should be a compatibility between the two. The connection should be such that a new connection is established between the xylem and the phloem, so that there is a nutrient and the water transport taking place between the root stock and the scion. As you will see, just understanding the anatomy of a tree, as a science student, you know each plant, each tree has an external bark. When you will see externally, that bark is called as the cork. That is formed from the cork cambium, and both the two or three are called as the periderm also. And then there is also a phloem. Next to it is the vascular cambium, and that vascular cambium is in the form of an annual ring. That vascular cambium is very important, which is basically a meristematic tissue, and that will form on this side the cells, on this side the cells, on this side it will form the secondary phloem, on this side it will form the secondary xylem. So that means this is the anatomy where you have these rings which are depicting the vascular cambium. And that is why when you are connecting the two, the vascular cambium is to be exposed, so that the two scion cambium and the stalk cambium will have a union, and when they will grow, they will form in connectivity. How we will select? What is the selection and the handling of a scion? You have to select a scion. Uh, First of all, you have to take the best quality of a scion. Scion wood should be good and should be taken from a shoots of a previous year. It should be preferably taken from the previous year. And scion should be severed with a sharp knife. Scion be placed immediately in moistened plastic bags to, to protect it from desiccation or the loss of the moisture. And then you have to sterilize the cutting tools. The sterilization can be done with flame sterilization, or you can use the sterilizing solutions, isopropyl alcohol. And also you should select a healthy scion wood. And also one more thing, that is you have to select a stock plant which is healthy and true to its type. So that means you have to select a cyan wood, and you have to select a stock which will be a robust root system, and make cyan bundles of uniform length. And you can label the cyan a date of harvest and the location of the stock plant. And you wrap the base of the cyan bundles in burlap or a sphagnum moss to protect it from desiccation, or you can seal them properly in a polythene bag, or you can dip their ends into a wax. And in case on a larger scale, you can keep them stored in a commercial storage units at 32 to 34 Fahrenheit, but you should avoid the deep freezing. That means selection of cyan is also very important. You are taking a plant where from you are collecting the cyan. So this is how you take a cyan piece, and you are making them into bundles, and after that you are putting them into these polythene bags, or you can dip the ends, both the ends, in a wax, so that there is no loss of moisture. Of course, you have to remove the wax when you are putting it into a stock. So this is how you select and handle a cyan wood. What we mean by the graft compatibility. See, majority of plants graft to themselves. It includes most of eudicots like angiosperms, which includes fruit trees, rose, grapes, tomatoes, and melons. There are certain basal angiosperms like magnolias, certain conifers, gymnosperms like conifers. They have a graft compatibility. Most monocots have lost the ability to graft because monocots have scattered vascular bundles. And they lack vascular cambium. Vascular cambium is important for the union, graft union. And at the same time, in monocots, leaf and stem's veins run in parallel. They may join each other at internode region. But when we graft that portion, grafting to some extent is successful, but the success rate is only 3%. That means monocots do not show a successful grafting because they lack the vascular cambium. And you will see with this photograph, there is a mismatch. When there is anatomical mismatching between the cyan and the stalk, so conducting tissues will not have a contact. It may be inaccurate. That's why when you make a union, the union does not hold true. The grafting is not successful because there is an anatomical mismatching, which is very important. So we will see the grafting done in case of the vegetables also, in agriculture also. So majority of plants will graft to themselves, few will graft with closely related species. Plants rarely plants successfully graft to distant relatives. So they should be some relative which have a good relation. Suppose certain exceptional plants include certain pear varieties can be grafted to apple, but you will see in grafting among family Solanaceae. It's out of my curiosity I have kept it here. Grafting among family Solanaceae, which includes potato, tomatoes, eggplant, and tobacco. Now you see a tomato scion grafted to a potato rootstock, Thompson and Morgan. Example is tomato or pomato. It produces both tomatoes and potatoes. Or we have a pomato, which is this pomato single plant will yield 3 kgs of tomatoes and 1.25 kgs of potatoes. So you are grafting a tomato and a potato plant together because they belong to one family, and you are getting both the produces. Or you have a bremato, that is a grafted brinjal and tomatoes, which is yielding brinjal and tomatoes. Scientists at ICAR, Indian Institute of Vegetable Research, they are working on a new plant that will yield brinjal, tomato, and chili. See, this is interesting. See, this is a tomato where you have a basal portion will produce the tomato, and potato, and the upper portion produces the tomato. So how you graft it, this picture shows it, because these are the two plants. One is a potato plant, one is a tomato plant. You are making a graft, you are cutting the aerial foliage here, and then you are putting keeping the root stock of one, that is potato, and then you are taking the shoot stock. So cyan here is the tomato and root stock is the potato, and then you are combining them together, and the result is you are getting both the crops. You have a root with the root stock producing the potatoes, and it produces the tomatoes, and the result is both the two vegetables are available. This is successfully done. And also Brimeto is a hybrid plant that gives both brinjal and tomatoes. It's made in Varanasi. You have one more, and that's called a brinjalo. Is a hybrid between brinjal and potato. It produces a potato, it produces a brinjal also. And then this is how ICAR, IIVR scientists working on a new hybrid variety that will produce, single plant will produce tomato, brinjal, as well as the chilies. This is how a grafting is being done in case of the vegetables. It has revolutionized the agriculture also, because from one plant you can get all the types of the vegetables. And just a reminder how it is being done, because the three things are taken here. One is the brinjal. You are taking a scion of a tomato, cutting its edge in such a way so that its cambium is exposed. Then you are making a cleft here in a brinjal, and putting this here, and then putting a polythene over it, making a graft union here, and then ultimately the graft is successful here. Now you have a tomato branch, you have a brinjal, and now what you do, you take a potato now. Potato root stock is available there. You will cut the aerial foliage of the root stock, and then you will cut this brinjal also and remove some of the branches of it, and will make a position in such a way that it is now inserted on a stalk. So you are exposing the brinjal now, and then making a cut on the root stalks of the potato, and then you are putting these into it, making a union. As a result, it will produce now what? A tomato, a brinjal, and a potato. This is possible in case of the agriculture, and the research is being done, and it being successfully done. Now coming to the types of the grafting. So you have seen the grafting is of it is beneficial to horticulture as well as agriculture. We have different types of the grafts: cleft grafts, side veneer grafts, splice graft, whip and tongue graft, saddle graft, bridge graft, and in arch graft. Let us discuss them one by one. What we mean by the cleft graft is a simple and the most popular method, a good method for both flowering and fruit trees. It is performed on main stems as well as on the lateral branches. A root stock should be 1 to 4 inches in dia, while as a shoot stock should be 1 by 4 inches in dia. So scion should be straight, long, with at least 3 buds. When you select a scion, it should have at least 3 or 4 buds. So how it is done? Cleft grafting is you are taking a root stock and you are making a cleft here, or with a clefting tool, and then you are taking you are preparing a scion which has few buds in it, and exposing the lower portion, and you can put them into this cleft and then cover it with the grafting wax, and there will be a union. That is, the dia of it is more and the dia of the scion is less. That is, it is in the form of a cleft. So you are using the scion into a cleft, and there will be an unequal trunk radius also. So this is how cleft grafting is done. You can do it in the roses also. You are cutting a plant, making a root stock, and then refining the root stock, making a cleft here with the help of a knife, two clefts you have made, and then you are taking the scion, making their edges so that their cambium is exposed, and then you are putting them into these clefts. Suppose four are put here, and ultimately you are tightening this area, so that they remain intact with the cambium, and then ultimately so that there is a union, and then you are putting a wax over it, which is called as the grafting wax. And then after a few weeks, what you will see, you will, and then you are covering with the polythene this, and you are finding that a union is successful after 3 or 4 weeks. As a result, this is a successful graft, and the graft is the union here is between, this is the scion, this is the stalk. So this is in case of the roses, how you can graft a rose, where you can put 4 scions onto one root stalk. And then you can do it on the lateral branches also, because a clipped can be done on the lateral branches. You are cutting the aerial foliage of a plant of a one branch, and then making a clipped here, and then you are taking the scion, which is you are defoliating it, and then making an exposure cambium layer, and then you are putting it, inserting it into this, and then covering it with a polythene, and then putting a tag, and then you will find this plant will have on side branches other grafts, which will be also possible in case of the clipped grafting. So this is one. Then second one is called as the side veneer graft. As you see the French word fournier, to furnish with a thin layer. It is a type of a side graft. You are grafting on the side, widely used to graft conifers, done usually on potted rootstock. Currently used to produce upright junipers and dwarf conifers. It was considered most popular technique for grafting camellias also. See how it is being done. You remove this portion here, a wedge from a rootstock, and you are cutting this here, and then you are taking a side branch, putting on this, and then tying it. So you wrap union and seal it with a wax. This is how it is done on the side of a branch. You can do it here also. This is a rootstock where you are making an exposure to the cambium layer, and then at the same time you are taking a scion and you are exposing it, and then you are contacting this with it. Two are contacted together, and then after you are wrapping it with the polythene, and then cutting this area so that a union is established between the two. So you are contacting the sides. That's why it is called as the side veneer grafting. So it is done in number of the plants which are successfully grafted with this type of a graft. This type of a grafting, which is called as the splice grafting. And you can do splice grafting on trees also. This is a rootstock, which is a plant, and you are taking a scion and then making a cut here with a grafting knife, oblique cut. And at the same time you are taking this is how you are cutting this rootstock, and then you are taking a scion and making an oblique cut there, making a small branch of it, and then having them to contact with each other, wrapping them with the material and putting certain wax over it, and then you are removing some roots of the rootstock, and then you can put them together. This will be it is scion, this will be it is stalk, and it has been done with the help of a splice grafting. So it is done in fruit trees also, and the idea here is that there will be more of the area available, more contact, more exposed area, where the more unions will take place through the cambium cells. Then one more is that's called the whip and the tongue grafting. As you know, there will be a whip and there will be a tongue. Both will be combined together. It's most commonly used to graft apples and pears. This technique is similar to splice grafting, except a whip on the rootstock holds the tongue of the scion and the vice versa. So we are making a whip and we are making a tongue. And it's compared to splice graft, it is stronger, because here interlocking tongues are held under compression. Natural elasticity of the wood of both stalk and scion helps interlocking. Though you see you are putting the stock and the scion together, and or you are using the wrapping material, but here one more thing is which is giving is more strength is whip and tongue, because there is a natural elasticity of the wood. It is both stock and the scion which helps their interlocking. So that means this is how you are preparing both. You are making preparation of the root stock is made here. यहाँ पे you are making a tongue, and here preparation of scion you are making a whip. And then how it is being, see, this is a root stock, this is a scion. Here it will overlap with it. It will be here which is getting inserted into it, and then you are covering it. As a result, this makes a natural, because this will have an impact on it, this will have an impact on it. It will be interlocking will be more stronger. This is called as whip and tongue grafting, as is done in number of fruit trees. Then one more is called as the saddle grafting. A popular method of grafting fruit trees also. Scion wood is smaller than the root stock. So easy to learn technique. Stock can be either field grown or potted. How it is being done. This is the root stock. You are making a saddle over it, and then you are preparing a scion this way, and then you are putting over it, over the whole area. See how it is being done. You are making a saddle and then putting the reverse of it, and then you are combining it with the polythene, covering it with the polythene, and also using all types of the waxes, and then there will be a union here which is called as the saddle grafting. So it is done, it can be done. The saddle is also made with certain these sketchers which are available. They are making this, and then you are making the reverse of it, and then it's fitted, and then you are using a tape which is called as the grafting tape. And how you are making a saddle graft by using a special type of a sketcher which is fitted to different diameters of the scions as well as the stalks. So this is the saddle type of the grafting. One more grafting that is called as a bridge grafting. Bridge grafting is a word which bridges the two. A graft used to bridge a damaged area of a plant. It helps to re-establish the interrupted sap flow. See, when a plant is damaged, either by an animal or naturally, it has a root stock, it has an aerial shoot, but midway there is a damage. And how it will be bridged? It will be bridged with a graft that's the bridge graft. So you have this area which is damaged, either damaged by the animals, and now there is every chances that there will be less connectivity, less strength, and you are using this area and this area, and you are putting a bridge between them. That is called as the bridge grafting. So this is how a bridge grafting is done to avoid a damaged area here. This is the area, you are exposing the area, and then you are removing these areas, the scions which will be used for it, and this is the damaged area, and then you are using these scions putting here, and then the top will be, this is the lower area where a rootstock is connected, and then you will find how at the aerial end. So this is the lower area, and then at the upper area it will be connected here. So this will act as a bridge. As a result, there will be a union. This area which is lost, it can be used. Then it can fungicides can be used, or it can be treated also. But at the same time, the plant will survive because the connectivity is through these bridges. This is called as the bridge grafting. And there is one more grafting that's called the bark grafting. Bark grafting is, as you know, the graft made by slitting or slipping the bark of the stalk. So you are using a stalk plant which has a bark, and on which you will insert the scion beneath the bark. It's used in top working and frame working. Two or more scions are inserted on a truncated branch. Relatively easy and very successful process it is, and done in spring after the bark begins to slip and buds are opening, because you have to take a bark and then you are inserting into it. Normally done from the end of the March to mid-April. Examples are mango, apples, and citrus and cherry. How it is done? This is, you are preparing a scion, you are flipping of the bark, and then you are inserting the side, which is this side will face towards the cambium, and then you are again reuniting this bark over it, and then putting a wax or a clay over it. And if you are putting three these scions on a rootstock through a bark, and then you are covering it with this, and then this will be the new plant which will be produced from the rootstock. This is called as a bark grafting. You are using a graft into a bark. This is done here, grafted apricot through bark grafting. See how it is being done here. You are inserting a scion of desirable trait into a rootstock, and then you are covering it with the wax and or this, and then these three branches will be becoming the new shoot system of the apricot. Then the last one is called as the in-arch graft. It is also called as the approach grafting. Approach grafting is means you are approaching the two plants, a method whereby two plants are made to unite while growing on their own root systems. So you are connecting the two, one plant, two plants, one plant is having a root system, another plant is also having a root system. You are connecting the two, and then they are separated when the graft union is complete. It is also used to bypass or support a damaged area of a plant system. Scion can be an existing shoot or a plant growing near the base of the damaged tree. So scion can be a existing shoot, or it can be a plant which is growing next. See, if this is a damaged basal area, this is the damaged basal area. We have a next plant which is growing here. We can connect it with this. It can be connected through this, and then once it is successfully connected, and then you can cut it. You can cut this area, and this is how in-arch grafting is done. Here you will see you are uniting the two plants here, taking one plant, making this area cambium portion exposed, and at the same time this root stock, another plant where you are inserting, you are making a tongue type of an incision, and then you are putting this into it, and then wrapping it. Whenever both the two will survive, because both the two have a root system, but you have to select one, because you are selecting the a scion which is having a good trait, and that time you have to cut this one so that it remains as a successful hybrid type of a plant. So this is how in-arch grafting is done to combine the two plants, and having their root systems intact until they become the fully united, and then you can cut one of the root stalks so that make a hybrid plant of desired trait. So this was the different types of these types of the grafts which is being practiced by both horticulturists as well as the agriculturists. And the question is, why to graft? As it is now clear to you, grafting may increase the productivity of a horticulture crop. It helps to change varieties and cultivars, helps to propagate desirable traits. Because you are taking a scion which has a desirable trait, you are taking a robust root system which is basically a drought resistant. So using a rootstock helps to take advantage of a particular rootstock, because you are using a rootstocks which have superior growth habits, which are disease and insect resistant, and which are drought tolerant, which has a drought tolerance also, and helps to perpetuate clones, because certain cuttings are hard to root. They will not root. But if you take those cuttings and put it on a stalk, it will be a successful graft, can be grafted on a rootstock seedling. So you perpetuate the clones, and helps to optimize cross pollination. You see, one of the advantages also, if you have a plant which needs a female plant for pollination, you can get one of the scion from a female plant and will plant it, graft it on the male, female plant. One male part on a female plant what will happen? A graft a scion from a male plant onto a female plant will ensure the good fruit set, because pollination will be nearer to it. This is how you can optimize cross pollination. It also helps to produce certain plant forms. Nowadays, this is a very good art and technique and is being used. You graft a weeping or a cascading form onto standard, produce beautiful plant forms. You get different types of plant forms, which is one straight, then can be weeping types, then can be other types. So this helps to produce certain plant forms also. Grafting is also helps to repair the damaged plants. As we have seen in arching or approach grafting, bridge grafting, they help you to repair the damaged plants, and also helps to increase the growth rate of seedling, because grafting reduces time factor. The seedling progeny of a horticultural tree requires 8 to 12 years, but grafting greatly reduces the time factor. See, normally you require a very good time, 8 to 12 years to have a fruit set. But when you take a scion and graft it on a rootstock, it can set in 2 or 3 years, even the same year. So that is, it reduces the time factor. And one more thing, which is for the research purposes, it acts as a index of viruses. Because you see, many plants are asymptomatic, though they carry viruses. The viruses are there, they are not showing the symptoms. The presence or absence of viruses in the plant can be confirmed by grafting scions from the plant onto a plant that is highly susceptible and will display prominent symptoms. So we can check whether the virus is there or not. That is some of the significances. This ancient technique is being used and has been used to produce the quality fruits and to produce the robust plants. And the grafting is done to produce on one plant. You can graft a number of the scions in case of agriculture, in case of horticulture, in case of floriculture. On a rose, you can have hundreds of varieties on a single type of a rose. And on a fruit tree, you can have, on the base of the compatibility, different types of cultivars are produced. And I think this topic, which was basically aimed for the nursery and the gardening students, it will benefit them. And I hope I have oversimplified it and have given you some idea about how you will graft certain plants using different types of the grafts. I hope you will like it, and you will continue to subscribe, and hopefully in the coming videos we will be focusing on different aspects of the plants. Thank you for your patient listening. Thanks, thanks, thanks.